In this video, we're going to go through two different calculations to solve what mass of a solid material can dissolve in a liter of water given the Ksp. For our first one here, what mass of silver sulfate can successfully dissolve in 1 liter of water solution? The Ksp is 1.5 times 10 to the minus 5. Go ahead and pause, see if you can solve that mass, and then come on back. Well, if you're back, what's going to happen here is our silver sulfate is going to dissolve into 2 silver pluses and SO4 2 minus. So we're going to have our solid silver sulfate salt. We're going to get some aqueous ions as they slowly dissolve. How much successfully dissolved? Well, Ksp 1.5 times 10 to the minus 5 must equal our products. So Ag plus to the second power times sulfate to the first power. And, well, the solid factors out, so we don't divide by it. So our Ksp is just equal to the silver concentration squared times the sulfate concentration. Well, as they're falling apart, for every 1 silver sulfate that breaks apart, I'm going to get 2 silvers and 1 sulfate. So whatever number of them successfully dissolve, I'll have twice that number of silvers, and I'll have that number of sulfates. So when we finally reach equilibrium, I'll have X amount of sulfate and 2X amount of the silver ions, which I can plug in as our unknowns. I'll have 2X of my silver, but I'll only have just X amount of my sulfate. All that will have to equal 1.5 times 10 to the minus 5. So what value of X would do that for us? Well, we have to distribute out our square, so it's going to square both parts on the inside. 4x squared times, well, 1 to the power of x, so times x, has to equal 1.5 times 10 to the minus 5, which means 4x cubed is equal to 1.5 times 10 to the minus 5. We'll divide by 4 and then cube root both sides. Our x is going to equal 0.01554. So this is what x would have to equal so that x times 2x squared will come out at 1.5 times 10 to the minus 5. This tells us the amount of sulfate, which is 1-to-1 with the amount of silver sulfate. So really it tells me the moles of silver sulfate. Technically we're talking about concentration here, but we're in 1 liter, so our moles is our molarity. And so 0.01554 mole of silver sulfate must have dissolved in that 1 liter. I can use that to find the mass of it. 0.01554 mole of silver sulfate, and every 1 mole of silver sulfate is 311.8 grams of silver sulfate, which is 4.84 grams of silver sulfate. So if there's a solid silver sulfate source and a liter of water over it and time is given for it to dissolve till it reaches equilibrium, 4.8 grams of that silver sulfate will have dissolved. Let's try a second one. Let's do a slightly different chemical. AgCl. So silver chloride. In this case, let's find the mass dissolved in 1 liter solution. And the Ksp, in this case, is 1.8 times 10 to the minus 10. So using this info, go ahead and pause. Find out what mass of silver chloride will successfully dissolve in 1 liter, and then come on back. Well, if you're back, this time my silver chloride solid is in equilibrium with a single silver and 1 anion, 1 chloride. So our Ksp calculation is a little different. 1.8 times 10 to the minus 10 is going to equal silver to the first this time, chloride to the first. So there's no square this time. We didn't have 2 of the silvers. We only had 1 in the formula. Well, as it breaks apart, I'm going to make some amount of silver, but I'll make the same amount of chloride, so these are both X. The unknown change, they'll be the same. And so as my silver chloride cell dissolves, I'll get equal amounts of my product. 1.8 times 10 to the minus 10 must equal X squared. Take the square root. X must equal 1.342 times 10 to the minus 5. Well, that's our concentration of the ions. So that's how many moles of ions. We're in 1 liter. So the molarity is our moles. In which case, 1.342 times 10 to the minus 5 mole of silver chloride successfully dissolves. Well, if that's the amount moles for every 1 mole of silver chloride, it's 143.3 grams of silver chloride, which comes out at 1.92 times 10 to the minus 3 grams. So if we compare that to our silver sulfate, 4.84 versus 0.00192. Just significantly more silver sulfate will dissolve. It is a much more soluble salt. Vastly less silver chloride will dissolve. And so depending on your source of material, it might be fairly easy to get a lot of soluble silver, or it might be very difficult to get a lot of soluble silver. There's various reasons you want soluble silver. A lot of times we use it for electrolyte solutions and things like that. But depending on what source you get it from, vastly different amounts may or may not dissolve. So Ksp values can range quite a lot. Here's 2 examples to compare, both with the same cation, forming wildly different concentrations of solution.